Unit 3 Review, Problem 6. Sierra College is considering the option to include plus and minus in the school's letter grading system. An opinion poll was conducted on campus in order to gauge the reaction to this proposed change in the college grading system. As a result, 58.7% of the 167 students polled and 43.4% of the 83 teachers polled were in favor of including plus and minus in the school's letter grading system. Estimate the difference in the percentage of students and teachers on campus who are in favor of including plus and minus in the school's letter grading system. Express the estimate both symbolically and verbally. So this problem asks us to estimate. So we will construct a confidence interval to estimate this difference in the percentage of students and teachers. Students and teachers are two different populations. Since students are mentioned first, we'll denote students as our first population, and teachers mentioned second, we'll denote them as the second population. So as we work this problem, we'll always label the student data with 1 and the teacher data with 2. And then when we enter the student data in the calculator, we'll enter the student data in first and the teacher data in second. And when we go to write our answer using words, we'll always mention the students first and the teachers second in order to have everything consistent with this choice of the students as our first population and the teachers are the second population. So we're estimating the difference in the percentage. The percentage is a proportion. So we'll be doing a confidence interval to estimate the difference in two population proportions. So we could use this as a guide to take us through the steps on calculating our confidence interval estimate. The first step in the confidence interval procedure is to select the level of confidence. We always use the 1 minus alpha of 0.95 or 95%, unless stated otherwise. And in this problem, there is no level of confidence given, so we'll use the customary 95%. Second step, on the TI-83, TI-84 calculator, we can use the 2PROP-ZINT command to calculate the lower and upper interval of our confidence interval. And the symbolic answer for estimating the difference between two population proportions is P1 minus P2. To find the 2PROP-ZINT command on the calculator, we press Stat, arrow over to Tests, arrow down till the cursor reaches 2PROP-ZINT, and press Enter. On the 2PROP-ZINT screen, you'll be prompted with X1, N1, and X2, N2. The X and N make up the proportion. X is the how many, the numerator, and N is the total, denominator. 1 is our first sample, which came from the students, and 2 is our second sample, which came from the teachers. So the X1 and N1 would be the total number of students who are in favor of the plus or minus grading system out of the N total number of students who are sampled. Now in the problem, we're given that 58.7% of the 167 students polled were in favor of the plus or minus grading system. The 58.7% is the proportion or percentage, not the X, the actual number. In this case, X1, the actual number, is not given. So we need to calculate it ourselves. To calculate X, the actual number of students who are in favor of the plus or minus grading system, when all we're given is the percentage and the total sample size, we merely find the X1 by multiplying the N1 times the P1 hat. So X1, the number of students who are in favor of the plus or minus grading system in the sample, is calculated by taking N, the total number of students, which was 167, and multiplying it by the P1 hat, the proportion, or 58.7%. When we enter this in the calculator, the 58.7% is written as a decimal, 0.587. So on a calculator, we would take 167 times 0.587, enter, gives us 98.029. But you must take note that x, the number of students, is discrete, whole numbers only. So we need to round the 98.029 number to the nearest whole number. And 98.029 is closer to 98 than it is to 99. So we're going to use x1 equal to 98. Same thing is true for the teachers. Here we're just told the percentage of teachers who are in favor and the total number of teachers who are sampled. We're not given x2, the actual number of teachers who are in favor of plus or minus grading. So we need to do the same thing and calculate for ourselves x2, the number of teachers who are in favor, by taking into the total number of teachers times p2 hat, the proportion of teachers in the sample. Into the total number of teachers in the sample was 83, times the proportion was the 43.4% of teachers. When entered in the calculator, 43.4% is written as a decimal, 0.434. So to calculate x2 on the calculator, we would take the 83 times 0.434, enter, and that gives us 36.022. Again, we must note that the x2, in this case, the number of teachers, is discrete. So we need to round off the 36.022 to the nearest whole number of teachers. In this case, it rounds off to 36. So now we have x, our total value, and n, the total sample sizes. So we can enter it into the calculator, starting with our first sample of students. x1 was 98 total students were in favor of plus or minus grading, out of a total of n1, 167 students polled. And x2 and n2, the second sample of teachers, x2 was the 36 teachers who were in favor, and n2, the total of 83 teachers who were polled. With these values entered, we then go down to C- level, the confidence level. And since no confidence level is given, we're going to use the customary 95% confidence level to make our estimate. So we enter the 95% in the calculator as 0.95 decimal. Now we go down with the blinking cursor on calculate and press enter, and the calculator calculates the confidence interval for us by giving us L, the lower bound, and U, the upper bound. Now we're ready to express our confidence interval both symbolically and verbally. Symbolically, the estimate of the difference in two population proportions is written as P1 minus P2. The minus or subtraction for the difference, P1 and P2 for the two population proportions. In an interval, symbolically, we surround it with the less than signs to indicate that this is being estimated to fall between the lower limit, which is on the left, and the upper limit, which is on the right. The calculator gives us the lower limit as the first number in the interval. In this case, 0.02292. And if we want to estimate this as the difference in the percentage, we convert the decimal answer to a percent by moving the decimal 2 places to the right. And then if we want, could round off, but make sure we round off carrying that at least one extra decimal place. So in this case, since the 9 is over 5, the 2 rounds up to a 3, and our lower limit is 2.3%. The upper limit on our interval is given on the calculator as 0.28326 decimal, which if we convert the decimal to a percent, we move the decimal 2 places to the right. And then if we look 2 places after that, there's a 2. 2 is under 5, under halfway, so we just round this down to 28.3%, thus giving our symbolic estimate of the confidence interval. 2.3% less than P1 minus P2 less than 28.3%. Now that we have the symbolic estimate given, we can now write the estimate verbally, that is, in words of the problem. So the difference in the percentage of students and teachers on campus who are in favor of including plus and minus in the school's letter grading system is estimated to be between 2.3% and 28.3% with 95% confidence. And this result is enough for us to complete this problem. But just as a note, when we write our answers in words of the problem, there's lots of different ways we can write it in words but still give a correct interpretation. So this answer here is just one way of describing the result in words. Another way is this. You could notice that the 2.3% and the 28.3% are both positive. And so when you're subtracting two numbers, in this case the P1 minus P2, and you're getting a positive difference, that's always the result of the first number being higher and the second number being lower. So if you take the first percentage, which is a higher percent, subtract the second percentage, which is a lower percent, a higher percent minus a lower percent always leaves you with a positive difference. So the fact that these lower and upper numbers are both positive lets us know that the first proportion is higher, which is students, and the second proportion is lower, which is teachers. So we can express this in another interpretation by saying, therefore, there is anywhere from 2.3% to 28.3% higher percentage of students than teachers on campus who are in favor of including plus and minus in the school's letter grading system. This is just two different ways of expressing the estimate in words. Which one you use depends on which one you feel makes the most sense to you.